Hello everyone. We're going to be talking about Project 2 conference presentation of cloud development. My name is Pedro Estrada. I'm a software developer. So the purpose of this presentation is to articulate intricacies of iCloud development to both technical and non-technical audiences. Containerization. We are going to explain the models used to migrate a full stack application into the cloud. We have map environment, AW application migration service, installing an agent, replicating to AWS, performing a test, and carry out cutover. A couple of the tools necessary, software component that wraps the code and all the dependencies to ensure that the application runs quickly and consistently across different computer settings. Docker container will be one of your most important tools, and it will contain a lot of packages, and it will run into the application. Going more deep into this, the map environment shows different cloud servers to migrate to the cloud. It also shows a physical and virtual development. The AWS migration system will change the source to run into AWS, so it will be a smooth transition from a full stack development app application or website into the cloud. The installing agent will just replicate every agent and source into the servers to make it easier for us. Replicating into AWS will continue to standardize operations where the servers are being duplicated. Performing tests will check on this serve test before cutover, so you'll check if you have any errors. You'll be like you're testing, and the cutover will be where the AWS is in motion. Orchestration. As I was talking earlier, the use of Docker Compose will be a key advantage. It will allow you to define your application stack in a single file. You'll maintain the project root, so you won't lose anything. You won't lose any source code that you will have. It will make it easy for anybody to contribute. It will be easy to put it into a website like GitHub or GitLab, so a lot of people will be able to interact with your code. And yeah. Moving to serverless cloud, it'll be serverless. As we're talking here, what is serverless and what are their advantages? Serverless solutions include an automatic scaling, building high availability, and pay-per-use invoicing mechanism to enhance agility and save expenses. These solutions will help you handle the infrastructure management, so the capacity and patching is good. This will allow you to focus on building software that benefits the customer instead of just focusing on the roots. S3 storage, and how does it compare to a local storage? S3 will be cloud storage. It will have the performance, security, scalability in the industry. It will be the best service that you'll have right now. It will store and maintain the amount of data range and use cases, including data. It will have backups. You'll have cloud native apps. It'll help you with analytics. So it's way better than storage, than a local storage. You'll be able to use everything on the cloud on the move. Talking about API and Lambda. So these are two services that AWS provides for you. There's a couple advantages to using a serverless API. It provides scalability and by automatically responding to changing traffic levels without the need of a person's interaction. This will ensure that the customer or the user has an amazing experience at its peak periods, even if a lot of people are using it. Another one will be that it's affordable. You won't have to pay that much. The hour time that you will use will be cut almost in half compared to using a server instead of a serverless cloud. They're not upfront costs. They're not penalties. The only thing you'll pay for is what you use. So this will decrease the requirement to upkeep it. It will provide any type of framework and programming language that you choose. Right? Whenever we talk about Lambda, we refers to the code or business logic used to manage requests and answers into the API built using AWS Lambda, right? It is required to write functions to handle various API endpoints, parse incoming requests, process data, take actions, and generate appropriate responses. Some of the scripts generated for these servers, just as the entry point, will invoke the function script, which provides the logic of each endpoint. This will help the configuration of the script, uh, which specifies the routes, authentication, the environment, variables. It will help you design serverless to accelerate the development and deployment of the process. So, yeah. Database. So we're going to be talking about MongoDB and DynamoDB. They're used radically. They're used and they're completely different. MongoDB uses flexible, schema-free, JSON-like documents to store data. It makes it possible to include complicated data kinds and hierarchy structures into a single text. The data is organized into tables with a primary key in DynamoDB, a key value database, and a large number of columns. Each project in Dynamo is key value part. It looks like advanced data types and hierarchy structure. Queries operate differently depending on the data models utilized by MongoDB and DynamoDB. Queries in MongoDB include text search, sorting, aggregation pipelines, and filtering based into specified document properties. When it comes to purely Dynamo, on the other hand, it depends heavily on the primary key. It supports key-based operations like get, put, delete, find. Provides the secondary instances for greater query flexibility, script building, programming languages such as JavaScript. Utilize the Node.js driver for MongoDB, on AWS SDK for DynamoDB. These scripts are the connections to execute the development, the responses to do any type of transformation that you'll need. Okay, moving to cloud-based development principles, we're going to be talking about elasticity and pay-per-use model. Elasticity refers to a system ability to expand or contract in response to changing capacity-related needs for computing and networking, storage, etc., etc. And whenever we talk about pay-per-use model, it's a method of charging for the cloud computing that is based on consumption. This technique is similar to utilize bills to save up money for the company depending on the use on the website and the cloud. Bye-bye. Securing your cloud app, you have the access. You will be needing encryption, tokenization, data decomposition, cyber deception defense. These are just to access and keep security. We'll have a couple policies in AWS as object. When it's linked to an identifier resource, identifies a permission attached to such an object. When IAM principal user role, it submits a request. AWS considers these rules whether a request is accepted or rejected. It's just like a tree branch. You'll have a yes or no if it's accepted or not, just for the permissions. Moving to API security, connections between Lambda and Gateway are secured by authentication and authorization. The database will always be protected by AWS. As y'all know, AWS is one of the safest storage, cloud storage in the world right now. And S3 is secured by data encryption while transmission. So you'll be able to stay safe while having a serverless application or website. And getting to the end of this slide, we would like to talk about what we talk all over. We'll have an understanding of cloud development. You'll be able to understand the principles and the history of it. We'll be confident that we'll talk about cloud security, as I say in the last slide. Everything is covered. And we'll be able to identify the key points on process scalability, storage the data. Amazing. Thank you very much for your time. I hope you enjoy. If you have any questions, please let me know.